Okay, geometry students, today we have our Unit 3 review for the upcoming semester exams. And this particular unit was all about parallel lines and the angles that are formed around them. So not a difficult unit, just a basic handful of rules that you absolutely have to know and accept the fact that this is the way it's going to work. And if you can accomplish that, it led us to a whole lot of success later on with dealing with certain polygons and the properties that they have. But it all started right here. Angles formed by transversals. Okay, so the first thing we came up with was a very basic definition of the word transversal. A transversal is any line that intersects two or more lines. Now, obviously, if we're going to talk about angles that are formed around intersections, then something has to be doing the intersecting. Okay, this line is just called a transversal. Now, as we found very quickly, it is possible to have more than one transversal running around in your diagram at the same time. Okay, so it can very quickly get very confusing and cluttered inside of the diagram. The trick to it, as I told you back then, is to only focus on one line at a time. So if you have multiple transversals running around inside of your graph, okay, it might be a good idea, use your hand or something like that and simply block out everything else on the paper that is not around the transversal that you're looking at. Okay, anyway, as one line intersects two other lines, which it could intersect more than that, but we'll just start with two. Okay, there are 8 angles that are formed, and obviously as our transversal starts intersecting more and more lines, we pick up 4 new angles every time the transversal hits a new line. Okay, those angles have categorical names that describe their basic positioning with respect to the two lines that are being intersected and the transversal. Okay, so we need to learn the basic names that were in there. Corresponding was a name that I told you back in the day. This was the one that people would struggle the most with, and y'all proved that to be true. Corresponding, it means they exist at the same basic location but at different intersections. So from this particular diagram we're looking at here, where again, we're not saying anything about their properties yet. We're just talking about their positioning. So like angle 1, when you look at the intersection near angle 1 is basically up and to the left from its intersection. So it would correspond to any angle along that transversal that is also up and to the left from its intersection, which would be angle 5. Angle 1 and angle 5 are corresponding angles, and so on for the rest of them. Okay, the rest of these uh, categories basically say what it is that they describe or what it is that they represent. Alternate interior angles. Really very simple. Alternate is referring to their positioning around the transversal. Alternate means one on one side and the other one alternates its side. So in this case, since the transversal, the red line, is basically up and down, mostly vertical, okay, we could say that alternate would mean one angle is going to be on the left of it and the other angle is going to be on the right of it. Okay, but of course at different intersections. And then interior refers to the space that is in between the two lines that are being intersected, in this case the black guys. Okay, so alternate interior would be opposite sides of the transversal, but in between, in the space in between the two lines, and of course at different intersections. So angle 3 and angle 6 would be alternate interior angles, so would angle 4 and angle 5. 1 and 2 and 7 and 8 are not used in this case because they are not on the interior space between the two lines. Okay, same side interior angles, you get the same basic explanation, only you're not on opposite sides of the transversal. We're not going to alternate this time, so we're staying put. Okay, so same side of the transversal, yet still on the interior space between the two lines. Okay, so we have like angle 3 and angle 5. Those are same side interior, and angle 4 and angle 6. Those are same side interior. Again, angles 1, 2, 7, and 8 are not used because they are not on the interior space between the two lines. Now, a synonym that goes along with same side interior angles is consecutive interior angles. They're just as likely to use one term as they are the other, so it's important to know both. Alternate exterior angles. Okay, obviously we've already talked about what alternate means. Exterior means not in the space that is between the two lines. So this time angle 3, 4, 5, and 6 will not be used because they are on the interior. So if we looked on the outside, like where angles 1, 2, 7, and 8 are, okay, alternate exterior angles would be angle 1 and angle 8, opposite sides of the transversal on the exterior space, angle 2 and angle 7 also. Now, as tempting as it may sound, for whatever reason, there is no rule for same side exterior angles, but it works basically the same as same side interior. Okay. Now, the only real catch to this, aside from learning the vocabulary, which we absolutely need to do, I told you that on day 1 of geometry class, the vocabulary absolutely will kill you. If you do not study the terms and the definition in this class, you will not pass this class. I think some of you are seeing the truth of that now that we are at the end of the year and possibly wishing you could have gone back and paid more attention to your vocab. Anyway, the thing that you absolutely cannot do with these types of angles is you must follow only one transversal at a time. Okay, from this diagram that you're looking at there, we can very easily say that angle 1 and angle 2 are corresponding angles. They are at the same basic positioning at different intersections that a transversal is connecting. Okay, same thing with angle 2. We can say angle 2 and angle 3 are corresponding angles because they're at the same basic positions at two different intersections that a transversal is connecting. But the transitive property does not apply here. We cannot say that angle 1 and angle 3 are corresponding angles because there is no transversal that is connecting their particular locations. Okay, that was that. The next thing we did is we came back and we started to apply some rules in here. Okay, and something happened to these 4 sets of angles, 4 types of angles, if the lines were, in fact, parallel. So let's say you're looking at a diagram. You say, oh, I've got a transversal in here, and the 2 lines that the transversal is intersecting, those lines are parallel. Okay, well, something starts to happen, and here's what happens. The corresponding angles that we talked about is the property that goes along with them. Wherever your corresponding angles are, they will be congruent. They'll have the same measurement. Okay, so hopefully in the previous lesson you identified their locations. Now that you know which ones are corresponding, if the lines are parallel, the corresponding angles will be congruent. Same thing is true with the alternate interior angles. Now that you know where they are and how to find them, if the lines are parallel, then your alternate interior angles will be congruent. Okay. The next one that we looked at was the same side interior angles or consecutive interior angles, and this is the one that is the oddball. Okay, now that you know where to find your same side or consecutive interior angles, their relationship is that they will be supplementary. They will add together to equal 180 degrees. And the way that we remembered this, remember as we said, all the S's go together. Same side supplementary, same side supplementary. Okay, so when you find your same side interior angles, they are the ones that will be supplementary if the lines are parallel. And the last one that we looked at was the alternate exterior angles, and just like the alternate interior, okay, if you know that the lines are parallel, then your alternate exterior angles are going to be congruent. Now, please keep in mind, it's not that the only 2 sets of angles in the entire picture that are supplementary are going to be the same side interior angles, because there are other angles in the picture that are not related by one of these 4 sets of rules. That does not mean that they may not still be congruent, and it does not mean that they may not still be supplementary. It simply means that we don't have a rule directly connecting the 2 particular angles that you're looking at. But if you look around the problem, maybe you have other rules that can allow them to connect to one of the 4 types of angles that you have. Rules like vertical angles, or perhaps using a rule like same side interior angles or corresponding angles. Maybe that can move an angle measurement to a particular location where you can have one of these 4 rules in play for you. Okay, so just keep in mind these 4 rules do not cover everything that is showing up in the diagram in front of you, but these 4 rules and the other vocabulary that you have to this point in this year, okay, that should unlock the mystery of any angle measurement that you might be looking at in this picture if your lines are parallel. Okay, so we went through some examples. The key is you've got to correctly identify what kind of angle you have. Okay, when you look at the picture above, you've got X degrees, you've got 110 degrees. Those would be same side exterior angles if we had a rule that went along with that. But like we said, we can use rules like vertical angles to move this 110 degrees or move the X degrees. Or we can use rules like corresponding angles in order to move our measurements. There's a lot of things that we can do. You've got to make the picture fit the definitions that we have. Okay, so we looked at several different ways of possibly moving it around. Okay, this particular diagram, this 2x plus 8 degrees and 3x minus 3 degrees. You got to know what kind of angles these are if you're going to know what kind of relationship they have. Well, these are same side interior angles. Okay, and if the lines are parallel, then same side interior angles should be supplementary. That means when we write an equation, we would add these 2 angle measurements together and set them equal to 180 degrees. This diagram here, 2x plus 8 degrees, 3x minus 3 degrees. What kind of angles are those? Those are alternate exterior angles. And if your lines are parallel, then alternate exterior angles want to be congruent. So when it comes time to write an equation, we would set these 2 angle measurements equal to each other. Unfortunately, these are rules that a lot of you never bothered to learn, and it has caused some of you to always try to make angles equal to each other even if they're not, or try to always make angles add together to equal 180 degrees even if they don't. It is not as simple as just saying, hey, here's an angle and there's another angle, they must be equal, because they do not have to be equal. It depends on where they are and how they are related to each other. Okay, and the last thing we did is the same thing we did with a lot of theorems throughout the year. We flipped it around and we looked at the converse. Okay, so the rules that we looked at the day before said if your lines are parallel, then here's what's happening with your angles. Converse is going to say, hey, if this is what's happening with your angles, then that means your lines are parallel. Okay, so same rules, different perspective. If you can prove that you have corresponding angles that are congruent, then that means your lines are parallel. If you have alternate interior angles that are congruent, then your lines are parallel. If you have same side interior angles that are supplementary, then your lines are parallel. If you have alternate exterior angles that are congruent, then your lines are parallel. And again, that does not mean that any other types of angles that you run into means your lines are not going to be parallel, okay, because our 4 rules don't cover all of the different types of angles that are in this diagram. You have to maybe manipulate the information a little bit, move some of your angle measurements around according to what kind of information you do have, and then maybe you can spot one of your 4 types of rules. Okay, so don't give up on a problem just because it does not particularly work out to one of your 4 types of angles. Anyway, that was a very easy chapter in the sense that there is not a lot of information in it. If you know your 4 rules, then you should know the converses of those 4 rules. And that was basically everything that you had to do for the entire unit. Okay, so there's your Unit 3 review. See you in class.